What is everything? How the entire world and everything we see around us is made? What is that basic constituent substance or material that makes up you, that makes up me, and every object with which we come into interaction in our daily lives? Yes, that's matter. But what is this matter? Do we understand it correctly in a way that it should be understood? Do we have a clear conception of this topic? Well, let's answer it simply so that we all can understand, including myself. Don't worry, you don't have to be a science student. This video is for all. So hey everyone, I'm Arkodeep, and the topic for this video is the nature of matter, mass and energy. What is matter? According to physics, matter is anything and everything that has mass and occupies space. The occupation of space is just its area that it takes to be at rest. Now, what is mass? If I ask you what is mass, you would simply answer that it's the amount of stuff inside an object. Well, that's the colloquial definition. According to physics, mass is the measure of the amount of resistance that an object offers against motion. I repeat, mass is the amount of resistance that an object offers against motion. Now, what does it mean? Let's imagine a situation. Here we have a ball, and let's imagine that it is surrounded by complete emptiness. There's nothing. I know it's hard to imagine, but that's an analogy. When it is at rest, it is offering a resistance against motion, and the amount of resistance is measured by its mass. This property is quite similar with the property of inertia. Inertia is basically the property of an object that resists changes in motion, and the amount of inertia or that resistance is measured by mass. So mass is nothing but the amount of resistance that it offers against the motion, thus called the inertial mass. Now, if I keep this ball on the gravitational field, surrounded by the gravitational field, a force of gravity is exerted on it, and the ball is at rest. So the forces acting on it are the gravitational force or the acceleration due to gravity, and here the mass is called the gravitational mass. That is, F is equals mg. M here is the gravitational mass or the resistance against gravity to be at rest. So inertial mass and gravitational mass are the same concept, are the same thing, both are the same. Now let's come to another topic, the momentum. What is momentum? Momentum is basically the product of mass, that is the amount of resistance against motion, and velocity. And Newton's second law states that the force we need to apply on an object to bring it in motion is equals to momentum over time. From here we get that explanation of F equals ma. So let us look into our next example. What happens when matter collides or object collides? So when these two balls bump into each other, there's somewhat a transfer of force. The motion of one gets transmuted to the motion of another ball. According to Gottfried Leibniz, he described this as a living force, a physical substance that gets exchanged when matter collides. Well, this is nothing but energy. What is energy? The literal meaning of energy is at work. And in classical mechanics, energy is the rate of doing a work. What is work? Work is somewhat different in physics compared to the work we do in our daily lives. Work is a product of force and displacement. So when I'm pushing an object, the total displacement it suffers from its initial position to the final position is multiplied by the force which I am applying. That is mass multiplied by acceleration. This is called work. If there is no displacement, if that object doesn't suffer a change in position, that means no work is done. Well, so let's understand it. Here's a ball. When it is at rest, it is offering some resistance against motion, and that's why it is in rest. And the amount of resistance is measured in terms of its mass. Now, if I lift up the ball I'm doing a work against gravity. Work is equals force into displacement. So there's a net displacement between the initial position and the final position. And the force which I am applying is equals to the momentum over time. Force is getting stored here. And here comes the concept of energy. Energy is equals the rate of doing a work, which is getting stored here as potential energy. Now, if I drop the ball, you see, the stored energy is converted into the energy of motion, that is the kinetic energy. So, energy is stored in mass. And here comes the concept of mass-energy equivalence. We cannot separate energy from mass. We cannot define energy independently of mass. They both are the two different forms of the same thing, like two different faces of a same coin. And Albert Einstein comes up here with the most influential equation in physics of all time. E equals mc squared, or mass equals E by c squared, whatever you may say. Mass is always equals to the energy over c squared, that is the speed of light squared. So from a tiny particle we can extract a huge amount of energy. Einstein says that energy can be also stored in mass. The stored form of energy is mass. Energy is always stored in an object as mass, as potential energy. And when the object is in motion, that potential energy is converted into the kinetic energy. But energy is always conserved. The most familiar example is that oscillatory motion of a pendulum. If the pendulum moves from this position to this position, the potential energy first gets converted to kinetic energy in its movement and comes back to the initial position. It doesn't reach beyond this initial position or comes down. It exactly comes back to the same position. That means that stored energy is first converted into the energy of motion, and again back in time it's converted into the potential energy as it comes back to its initial position. So, the recap is that matter is everything that we see all around us, and it's something that occupies space and has mass. Mass is not the amount of stuff in an object, but rather it's a measure of the resistance of the object that it offers against motion. And energy is nothing but the rate at which a work is done, and according to Einstein, energy can also be stored in mass. Mass is the frozen form of energy. This is the nature of matter, mass and energy. This is a very basic concept, but if we go in depth review of this concept, it becomes more and more complex, and mathematics has a huge role in understanding these concepts. So that's all for today. See you in the next video, and remember, it's all about physics.